All right, so let's go ahead and figure out how we could find the p-value for this data, both from the test statistic and from the data itself using StatCrunch. So we're going to look back at that activity that you did leading into this section. So if I go to StatCrunch, first I already know my test statistic. Our chi-squared test statistic was 8.67. Let's go see if we can figure out what that p-value is that they gave you on the next screen in StatCrunch. In Desmos. So first, if we're talking about a distribution and a p-value, we know we're looking for a probability. So we probably want to come to calculators and, oh, there's a chi-squared calculator. This is where things get a little bit funky. Let's just see what happens here. So we know what our degree of freedom is. Remember, degree of freedom, they told us in StatCrunch was 3. We had 4 categories, we subtract 1, so we're down to 3. So degree of freedom is 3. And we know we have a chi-squared. I'm going to change this to a greater than, but we'll see if that's the right thing. 8.67, what was it? They said 4, I see 1, 3. Let's just do mine, 1, 3. And I'm going to press compute. I chose to change this to do a greater than or equal to because I know p-values are all about being extreme. And if I had left this as a less than or equal to, I'm shading the majority of the curve. So greater than makes sense for our hypothesis testing. In fact, this is how you would find any p-value for these particular problems. So we end up here, we get out a p-value of 0.034, exactly like what was in the StatCrunch pre-activity. So there you have it. That's how you could go from the test statistic to a p-value using our knowledge of probabilities and these calculators in StatCrunch. We could also have done this immediately with our data. If we want to do it this way, we have to create some values in our in StatCrunch ahead of time. So we have to have a column for expected. Come on. Oh, actually, let's do observed first because we'll do it the same as our table. We can have a column for expected. And we can just put in our numbers, right? And I haven't actually put what they were, response. I should have put that first, but it's okay. Very satisfied, satisfied, unsatisfied, and very unsatisfied. Way too lazy to type those out. And we could put our values, 110, 93, 78, and 19. And we expected 120, 105, 60, and 15. Great. We could manually do this. It is possible within StatCrunch to actually go ahead and say like, okay, I want to compute something. I want to make something like my O minus E. Oh, I have to build it. So let me go ahead and build it. You could be like, I want to do observed minus expected. Okay, let's call this thing, that was what I was doing before, O minus E, and compute. And StatCrunch will add you a new row. So you can actually do this. You could do this in Excel too if you wanted to, right? In Google Sheets, in any of these. We could create the whole table that was in StatCrunch. But we don't need to do that. If we go to Stat, you see one of the options, there are other things, but we have this goodness of fit. And one of the options is a chi-square test. So we're doing a chi-square goodness of fit test. We need to tell it where our observed are, which I labeled. We can tell it where our expected are. If we were doing that, we thought they were all equally likely, we could just click that button. We don't need to put those in the actual values, but we had different proportions for each of them. And yeah, let's go ahead and let's add the computer. Let's add that too. So we can see we end up with a chi-squared test statistic of 8.6714. We had 8.6713 with a p-value of 0.034, same as we got. So this is how you can do a chi-squared goodness of fit test within StatCrunch. You don't need to do all the calculations that we did in the pre-activity or using that table. You can just make sure your observed and expected are in these two columns and click a button.